Hello, I welcome you all to this another interesting screencast. The problem reads the ball at A is kicked with a speed of VA equal to 80 feet per second and at an angle theta A equal to 30 degrees. Determine the point x, negative y where it strikes the ground. Assume the ground has the shape of a parabola as shown. The second problem, the ball at A is kicked such that theta A is equal to 30 degrees, similar to the other case we are just from reading. If it strikes the ground at B having coordinates x equal to 15 feet, y equal to minus 9 feet, determine the speed at which it is kicked and the speed at which it strikes the ground. Both these problems are coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So theta A is equal to 30 degrees. Okay, this is equal to 30 degrees for both cases. Let's remind ourselves of the fundamental equations that we're going to be using. Velocity is the time derivative of position, and acceleration is the time derivative of velocity. And then we have one derived equation from the two equations. And if we were to, from these equations, we can derive a number of different equations. We have one common type of problems where we have acceleration equal to AC, which is constant acceleration at t equal to 0. We have S naught and V naught. Right, so the derivation for these equations, the results are S equal to S naught plus V naught t plus half AC t squared. Then we have V final equal to V naught plus ACT. Then we have V squared equal to V naught squared plus 2AC S minus S naught. Right, so let's write down the components of VA. VA will have two components. One is in the vertical, like so, and the other one is in the horizontal, and the one in the horizontal is constant. And then we expect VB here will have 1, that is final velocity at the time when it hits the ground. It will have also two components. It will have one vertical, and then we have vertical, and then we have the horizontal one. Like we said, this one is constant, so it's the same throughout. All right, so let's say this one is VB, like we said, and then we have this one is, because let's call this angle theta here. We'll have this one, which is VBX, and we said it's constant throughout. When velocity is constant, what is the acceleration? Equal to 0. So this one is VAX. And this one is VBY. Alright, this one we have is VAY. Okay. And this one is VAX. And then we know that VAY is just equal to sine is equal to VA, and VM is equal to VM sine the angle, which is the same for both cases. And then we have VAX, which is equal to VA cos 30. Alright. We are dealing with feet per second, so we need to calculate convert the acceleration. So we have 9.81 meters per second squared. 1 foot is equal to 0.3048. Alright, meters. So meter and meter cancels. Then we have 9.81 divided by 0.3048. So this one gives us a 32.19. Okay, feet per second squared. Okay, so our AC is equal to minus 32 minus 32.19 feet per second square. Alright, start with case 1, which is a 12-91. Right, so under this we are going to have horizontal and vertical. Let's start with horizontal motion. Horizontal motion, of course, for both horizontal and vertical, we are going to use this equation. So it is S equal to S naught plus V naught T plus half AC T squared. Our S in this case is equal to X. Our S naught is equal to 0. Our V naught is equal to VAX, which is equal to 80 cos 30. And AC, since this motion is constant, the acceleration is equal to 0. Therefore, we'll have X equal to 80 cos 30 times T. Okay, let's go to the vertical motion. Vertical motion, we are using the same equation again. Alright. Our S in our case is minus Y, and Y is equal to minus 0.04x squared. And then V naught is equal to VAY, which is equal to 80 sine 30, which is just equal to 40. And our AC here is equal to, remember we calculated AC. AC is equal to 32.19. Therefore, we'll have minus Y equal to 40 T minus half 32.19 T squared. Right, since we know that Y is equal to, so we can replace this Y here. We already wrote down this Y, so let's replace this Y. We replace this Y here. So once we replace that Y there, it's minus and minus, so this just becomes a positive, so that this just becomes 0.04 x squared equal to a 40t minus 32.19 divided by 2. This is 16.095 t squared. So let's replace this x, we replace this here. Okay, once we do, then we'll have we can write this as 16.095 t squared. Okay, right, so we can say 0 equal to 40t. We take this the other side to be minus 0.04. Again, if you do not want to replace x, you can replace t directly so that you find x. But for me, I prefer this because I do not want very long equations. Okay, 0.04. Then we have 80 cos 30 t x so squared and minus 16.095 t squared. Then solving for t, this just becomes 0 is equal to t factoring out t. Then we have a 40 and minus 0.04 by 80 cos 30 by 80 cos 30. Okay, and then it's been summed up with 16.095. So this becomes a 208.095 t. So we have t equal to 0. We have another t equal to that's 40 divided by 0.8.095. So it is a 0.1922 seconds. So we have two values of t. So we are going to use one of the values, of course, not t equal to 0, of course. We are using the other one, which is t is equal to 0.1922 to find the value of x. This is the time it takes for the ball to move from A to B. It takes 0.1922 seconds. Okay, so let's find, we are going to use this equation to find x. So our x is equal to 80 cos 30 t. Okay, and our t is equal to 0.1922 seconds. And then we also know that our y is equal to minus 0.04 x squared. Therefore, our x is just going to be equal to, replacing the time in there, we have 80 cos 30 times 0.1922, and this gives us a 13.32 feet. Okay, let's find what y is. This is minus 13.32 times 0.04, sorry, 13.32 squared times 0.04. So what we get is a minus 7.10 feet. Okay, so we are done with the first case. Let's go to case number 2. And this is 112-92. Okay, So in this particular case, we've been given x and y, and we're being asked to find VA and VB. So we use this equation that we've already defined, this one and this one. Okay. We only change where we have 8 to replace with VA. So we do have x given in the first case is equal to 15 foot, and also y is equal to minus 9. Okay. So then, given this information, then we can say 15 is equal to VA cos 30 in brackets T, and the other one is minus 9 is equal to VA is equal to VA. This 40 was so it's VA this is cos, and then this is VA sine 30 minus 16.095 T squared. Alright, I'll make VA subject to the formula here. Also VA is equal to 15 divided by T cos 30. So I'll replace VA here. Like so. Alright. And now, so once we replace VA there, we're going to have a minus 9 equal to 15 T cos 30. 15 T cos 30 by sine 30 by T minus 16.095 T squared, and therefore our T, making T subject to the formula. Okay, maybe let me write our equation. So this just becomes 0 is equal to 15 tan 30 plus 9 minus 16.095 T squared, and therefore our T is just going to be equal to we have 15 tan 30, okay, and then plus 9 divided by 16.095 square root of that. So plus or minus, we're just interested in the plus. That's 1 point. We have a 1.05 seconds. Alright, so that is the time in the second case it takes for the ball to move from A to B. But of course, you're interested in VA. So let's use this equation to find VA. So we know that our VA is equal to 15 divided by T cos 30 degrees, T equal to 1.05 seconds. And therefore, our VA is just going to be equal to, that's 15 divided by T, which is 1.05 cos 30. So this gives us a 16.50 feet per second. So we have VA. So now let's find VB. So let's find VBY, because VBX is a constant. is equal to VAX. So let's find VBY. So using V equal to V naught plus ACT, which is this equation here. Okay, we will find VBY, and writing VBY here, it becomes VBY is equal to VBY is equal to V naught, which is VA, sine 13, and minus 32.19 times T, which is 1.05. Mind you, we already found what VA is. It is 16.5, and therefore our VBY is just going to be equal to, replace those values there. We have 16.5 sine 13 minus 32.19 by 1.05. So we have a negative 25.55 feet per second. Alright, so we know that our VBX is equal to VAX, which is equal to VA, which is just 16.50 cos 30. So our VB is just going to be equal to square root of VBX squared plus VBY squared, and calculating this, our VB therefore is just going to be equal to, so we have 16.50 cos 30 squared plus VBY, which is a 25.55 squared, and then square root of that. We find that our VBY is just equal to 29.27 feet per second. I think we are done. Let's just outline the solutions. So we have the first case, which are the components, the y and the x component. There we go. And then we have VA in the second case, which is the initial velocity. And then we have final velocity, VB. Okay, at which the ball strikes the ground. So I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.